What? Gosh. Oh, should have done this. All right, guys, any questions before we get back in looking at this handout? We have to finish these hobbits off. This is our walk into Mount Doom. All right. Okay, all right, so let's get back into it. So if you were not here yesterday, the video's up. We did all these problems up here. We do have this problem left to do here. All right, so let's see. Can somebody tell me what that angle there would be?
$25.
Yeah, 25 degrees. Right. Again, I'm not going to do it again. I could turn the paper around and put this in the base, but it really doesn't matter. I could look at this as the base also. I really want you guys to understand that sine, if I do sine of 65, then this is the y-axis and this is the x-axis. Right, so I would have to look like that. Have my 65 in the base. This would be related to cosine, this be related to sine. If I look at the 25 degrees, I'd have to do this. This would be related to sine, this would be related to cosine. Okay, I like it. That is the one thing out of, I don't know, 80 things. That is the one thing that SOHCAHTOA does better. All right, sorry. I will continue to shit on SOHCAHTOA, I will. But there's nothing wrong with it, it's fine, you can use it. Just don't make it a crutch. So go ahead and finish this out. Go ahead and figure out these two side lengths of this triangle in any fashion you want to. There are multiple ways to do it. So just to be sort of generic, I'm going to label this one A, I'm going to label this one B. Just so I can handle any which way you happen to do this. So did somebody find the length of side A yet? Whatever you called it. Maybe you called it. How did you do it?
For A, I called it y, and I did sine of 25 equals y over 40.
Aw. Okay. That A looks like a 9. I like it. So yeah, so if you use this angle, then this is going to be the y side. So it's going to require sine. If you use 65, then it should say cosine of 65 equals A over 40. I like it. And part of the homework points out that something like sine of 25 equals cosine of 65. So that just makes sense. They both equal A over 40 in this case. All right, how's everybody doing out there? We haven't done much yet, so. And so A equals 40 times sine 25, and then whatever the hell that is. It's trying to be degrees, damn it. I would say it's 18.61. I don't know, I'm doing that in my head, so don't Hold it against me. Shit, I was way off.
I was gonna say, do you want to know what it is?
Yeah. Go ahead.
16.9.
Yeah, okay. All right. I'm cool with that. I can't do sine 25 in my head. I think I can give myself a break. So if I continue using this angle to find b, I'm going to have to use cosine because this would be like the x side here. So cosine of 25 degrees would be b over 40. So b would be 40 cosine 25. Now, some of you guys might say, well, I just use Pythagorean theorem. There's really nothing wrong with that. I wouldn't take points off, but can anyone remember why using Pythagorean theorem here might not be the best way?
It'll probably be off by a few decimals.
Because that's a rounded number, right? And here, neither of these are rounded. They're exactly what they are in the problem. Yeah. I don't know how far you'd be off. Probably not by much. So if I do this, I get 36.25 roughly. Now be really careful. And by the way, that's not a degrees or something. Yeah, there. On a test or a quiz or something, I might put units on this. So therefore your answers would have to have units, the same units, obviously, right? On this one, I didn't give them units, poor little dudes. Okay. All right. You know what really sucks about being remote is I don't get as much feedback from your faces because I can only see so many. All right. Has anyone tried this one out? Has anyone given that a try? Anybody? Jordan says yes. Rio has. All right. Austin, maybe so. And everybody else is just waiting. Okay. So if you haven't tried this one out yet, go ahead and try to set something up. Now's the time to get all the mistakes out of your system. Just do it. Whatever the hell seems to make sense, try it. Obviously, if your answer is something like 3 feet, you're probably wrong. If your answer is negative 80 feet, you are definitely wrong. So, and most of the time when you get stuff like that, it's because you have your calculator in the wrong mode. By the way, just to talk about how this makes sense. If you're looking up at the top of a building, so guys, just imagine you're downtown San Diego, it's a tall building, you look up to the top of it, right? There's an angle that you have to look up to see the top of the building. Everybody with me? If I walk towards the building, if I get really close to the building, do I have to look up more to see the top of the building or less?
More.
So it kind of makes sense in this problem. If they're this far away, they look up 32 degrees. If they walk another 775, now they got to look up 35 degrees because they're closer to the freaking building. It takes up more of the space in front of their eyes. So they have to look at a higher angle. All right, so that's the physical nature of this problem. That's why this problem makes sense.
And if you've got your face right up on the side of that building, you have to look straight up it.
90 degrees, baby. That's right. So when people just kind of walk and then hit their face in the side of a building, other people are like, did you have Waller for pre-calc? Totally. Gonna smash my face up against buildings now. All right, so let me ask you this. How many right triangles do you see in this problem?
2.
Two. Yeah, 2. Somebody could argue more, but yeah, there's 2 main right triangles. So for each one of those, I can set up a trig function relating the sides that I know something about with the side that I want to know something about. So this isn't always going to happen, but most of the problems you see, you're going to be able to say this. Which part of each triangle do I not give a shit about? In this case.
The hypotenuses.
Yeah, I really don't care what the hell they are. Poor little things. Who cares? Right? They're just my line of sight. There's nothing physically there. I don't care about them. So let's see. Somebody who has not talked to me yet. There is a big triangle and there is a small triangle, right? There's the big one. And there's a small one. Or smaller. Poor little dude. I'm not small. Shut up. So for the red one here, for the small one, what ratio can I set up? What trig function should I use? And what ratio do I set up for it? Someone who hasn't talked to me yet. Don't make me do this. Don't make me actually call on somebody. I always hate when I do that.
Cosine?
Cosine would be, what's on the bottom of the cosine ratio? Cosine is x over what?
Hypotenuse.
Yeah, and the hypotenuse is the side that doesn't come into play here, right? So considering that I know something about this side and I want to know something about that side, what trig function? So see someone else. I'm going to call on somebody and then I'll find out you're not really here and then that'll suck. Oh, I love you guys so much. Which trig function relates those two sides? Somebody.
Tangent.
Yeah, all right. So tangent of 35 degrees. And then how do I set up the ratio?
Opposite over adjacent.
Sure. So it's the y side over the x side. So it'll be
Yeah.
h over x2. I like it. I have no idea why I call that x2. I think I changed this problem around, but anyway. All right, now why does this equation suck?
We don't know anything about it.
Well, we know this side. I could throw it in the calculator and get a number, but the problem is the number of variables is too damn high, right? Too many damn variables in this freaking thing. So that's why there's a whole other triangle. So what can I write about the blue triangle, the big triangle? This would be the same idea. It'd be tangent of 32 is the y side, but what goes on the bottom now?
775 plus
Good.
x sub 2.
This entire side, which is 7075 plus x2. Let's do this. Let's just call this x. Get out of there. Just to make this easier to write. All right. All right, now here is where, all right. Now, between the two variables involved, which variable do I not care about to answer this question?
X.
X. I do not care about X. I don't need it. The question is about the height. So if I took this equation, which letter would I solve for so I could then substitute in the other equation?
X.
X. If I solve for X, I can get rid of the freaking thing. Does everyone remember that neat little, those just switch? So now in the other problem, let me see. Let's clean this other problem up just a little bit. Let's go ahead and multiply this up here. And now where it says X, I can replace it with this. There's a problem, I think, in the homework that's like this. I'm pretty sure there is. What's wrong with this equation? Look, Hey, it's solved for H. Yay. Is that a true statement? I mean, I kind of had a tone.
There's a secret other H.
Yeah. Not very good at being secret. He's right there. Right? So how the shit? What do I do? What the shit? How do I solve for H? In fact, don't say anything. Just do it. Solve it. And then I'll come in afterwards. So again, try something. If you have no idea, try something. Try it. I'm not going to look at your stuff. I'm not going to look at your work unless you hold it up to your camera. So try it. Try something. You might get it right. What the shit? So just to give you a little hint, one thing that sucks is this is all stuck inside the parentheses. So I'm going to distribute this little dude. I'm going to write that in a weird way just because. So I just distributed this. Because now, well, I'll shut up for a minute. All right. So now I can take and subtract. I can get all my H stuff together. By the way, if you really wanted to, way at the beginning here, you could put like A here and B here, right? Remember that stuff when we had natural log? It's kind of gross to kind of keep track of. That's always an option. Let's see, what do I have? So now I'm going to factor an H out. Oh my goodness, that's a lot, right? And then I'm going to divide by this. All right, so that'll be my answer, whatever the hell that is. Shabba! Okay, so let's see if we all get the same number. Are there any major Lord of the Rings geeks out there?
Not major.
Okay, but sort of up there, huh? This might be beyond. I mean, I think you would have to be like an extreme geek to understand that this is the correct answer for this question. There's an official accepted height of Mount Doom based on statements made in the book. So just in case I had a major Lord of the Rings geek, I looked it up to make sure I got this right. Does somebody have the answer? You guys, are you able to put this in the calculator correctly?
Is it 4,500?
Yeah. It's like 4,500.9 something, right?
Yeah.
Yeah. So it's officially accepted to be about 4,500 feet tall. So not very tall, but to a hobbit, that would be incredibly tall.
It's like Julian, right?
Yeah, it's not bad. All right. Throw in some lava though, and then it doesn't matter how tall it is. It's still freaky. All right, guys. All right. So I'm a little concerned about. Hopefully, you're all doing okay with this. You have got to bombard me with questions if there's anything you don't follow. You're going to have to be able to do this kind of problem on your own. Most of number 5 is algebra. The biggest expanse of work we did in number 5 is algebra. The first 2 steps were trig. The entire rest of the problem is algebra, right? And kind of understandably, people don't do so well with algebra because maybe it's been a while, whatever. But you really, really have to ask me a question if there's something that has happened that you don't see how it happened. All right. I'm going to stop pleading for questions. Okay, so that's that. There's one last thing in chapter 7 that I need to do, and then we're going to get into chapter 8. All right, so I'm going to shut this down. Everybody ready? I'm going to stop sharing. Bam. And I'm going to turn off my black hole here. Oh, let me make it all about me. Bam. Oh man, there's chats. I can't do the chats. Oh, I'm sorry, guys. I totally missed your chats. Okay. Let's see. So there's one major thing left from this. All right. So there's one little tiny thing that's called an identity. Does anyone remember mathematically what an identity is? It's not just a really good movie with John Cusack. That is
Fact.
I like it. Yeah. Officially, it is an equation that is always true. It is actually more of a definition, to be honest. So an identity is an equation that's not contingent on the variables in the equation. So what do I mean by that? Like, it also means something else, by the way, in case anybody is thinking multiplicative identity, additive identity, but no. This is related to equations. So here's a very, very basic identity. Is that only true for certain values of X? Oh yeah, Charles, you're right. That's another identity. I love it. Is that only true for certain values of X? What do you get when you distribute this?
Same.
The same.
X
So
minus.
it's like a demonstration of the distributive property. So this is an identity. The solution is all real numbers, right? Okay, so we're going to get a lot of trig identities. Charles pointed out in the chat that we actually have those reciprocal identities, for example, right? And they're identified as such. But we're going to get some more complicated identities. So this one is the most foundational trig identity. Right? That's not like a reciprocal identity. So there's a lot of different ways to come to this, but let me do this. Oh, let's see. So let's do this. Let's do it this way. What's the cosine of an angle? Defined to be the most basic definition.
X over H.
Sure, I like it. X over H. Well, let's make it X over R. Just, is that cool? Because I could look at it as the hypotenuse of a triangle. I could look at it as a radius of like a unit circle or a radius of a circle. Okay, either way works. And of course, what's sine theta?
Y over R.
Y over R. Okay, I like it. So what is, let's see. Also, if I have a circle, of radius r, what is the equation of this circle? X squared plus y squared equals
R squared.
r squared. I like it. So there's a few different ways. I think I've just decided to do this a different way. So watch this. Hopefully you guys remember this. This is the equation of a circle at radius r. That's the equation of it, right? So let me start with that. What do I get if I divide everything by r squared? R squared divided by r squared is 1. What is x squared over r squared?
Y squared.
No. What is?
X
over R.
Oh, no.
Okay, well, all right. X squared over r squared is x over r squared plus y over r squared. What is x over r?
Cosine of theta.
And we put the little square in the middle. I think have I talked to you guys about that? I think so. Plus y over r is sine. So that is the most fundamental trig identity. It's called the Pythagorean trig identity. And I'm going to put it in the order it's normally seen. Sine squared theta plus cosine squared theta equals 1. And this kind of makes sense. This is the y piece of a triangle in a unit circle. This is the x piece of a triangle in a unit circle. So you would expect when you add their squares, you get the radius, you get 1. And you can actually, there's the proof of it right there. So this is neat. This is always true. This is insane. So what does that mean, Jeff? All right. So what's a different way I could do this kind of problem now? We did a problem like this before, but there's a different way I can do this problem now. What if I have a triangle, an angle in quadrant 3 with, you can do it, Jeff, cosine theta equal to 3/7. Jeff, negative. Okay. Is everybody with me? Everybody understand what I just did? In quadrant 3, what's true about sine and cosine?
Both negative.
Yeah, quadrant 3, they're both negative. I like it. So I had to be careful. All right, now, one way we did this, we did a problem just like this last time, is I drew a triangle in quadrant 3 and blah, blah, blah. But look, can't I just use this guy? If I wanted to know what sine, what is sine theta? I could just use this guy. So sine squared theta plus cosine squared theta is 1. You guys okay out there? You guys? Okay. Sine squared theta equals 1 minus 9/49. Is that cool? So sine theta equals the square root of 40/49. But be careful now. What do I need to put on here? So if I take a square root, I officially put plus or minus, but which one do I pick?
Yes.
Yeah, the negative. I like it. So we know that when we take a square root in an equation, I have to put a plus or minus. There are situations where it's got to be positive because maybe it's the side of a shed or something. But in trigonometry, it depends on which quadrant I'm in. You have to pick the correct sign when you take a square root. I like it. So then sine theta is, you can simplify the top, you can simplify the bottom. 4, square root of 4 is 2, and you're left with 10 and blah, blah, blah. All right, sweet. Anyway, so that's another way to do a problem we already did. Why does it match with the math of the other way we did it. When we drew the triangle, all right, this is a little bit tiny. Let me make it a little bit bigger. So if I draw the triangle, Jeff, when I draw the triangle, I can figure out which side's going to be -3. I can figure out which side is 7. And then what's the very next thing I did? What's the very next thing I would do?
Pythagorean, oh no, well, yeah.
Yeah, Pythagorean theorem, which is basically what that is. So mathematically, I do the same math. I just do it in a different order, which is neat, but it feels very different. Oh, let me see. Somebody's asking, how do I do 1 minus 9/49? What's 1?
9/49.
Yeah. So then 49/49 minus 9/49. That's where the 40/49 comes from. Is that cool? Okay, got to get them like the manage. Oh, okay, no worries. Yeah, that one's from there. I like it. All right, so that's basically the last thing in chapter 7 that we had to talk about was that trig identity. There's an entire chapter coming our way that's all about trig identities. How many trig identities are there, you ask? There are roughly 18 billion. And I'm not really lying, to be honest. It's not 18 billion, but it's basically, it sort of is in a way. How many are you going to need to memorize? I will tell you exactly how many. I have a chart. I have a handout that has all these trig identities on it. There's a black line down the middle, roughly. The top ones you have to remember, and the bottom ones you are not required to remember, to memorize. So when we get to the point where we start talking about more identities, I'll publish that sheet so you know exactly what you're responsible for. Yeah, I like it. So I have got some really cool animations that I want to show you, but I want to do a little bit of laying some foundation down first. I kind of teased this last time. We have not yet graphed any trig function. So when I do this kind of thing, that is not graphing a trig function. I can calculate the values of a trig function for a given angle, sure, but it's not graphing the trig function. To graph the trig function would mean every input has an output, every input has an output, and I plot the points. We have not done that yet. I think most of you guys kind of know what a sine wave and a cosine wave look like, right? You've seen this in the background on oscilloscopes in horror movies. We're just wobbling around. Some of you guys, I don't know if anybody works with sound, anybody like a sound engineer or work with music a lot. If so, you've seen, you have to play with the gain and all this kind of stuff. Okay. All right. So what do we do to graph a function when we have no real idea what it really looks like in detail? We create a table, right? So we're going to graph sine and cosine. So let's graph sine first. So to graph this, I'm just going to have an XY table. What should I use as an input? What's a good place to start?
0.
0, sure. I love it. There were other answers I would accept there, but we'll start with 0. 0 is a perfectly good starting place. Now, how should I put 1 here? No.
No.
You're ready. Oh, baby. Oh, baby. All right. One thing I want you guys to realize, do not let your brain think that that is less than that, right? Because I'm dividing. So when I divide by bigger, it's smaller. So don't think I put those in the wrong order, right? All right, let's just deal with this for right now. So I'll put up here sine x. Okay. So what's the sine of 0?
1.
Say again?
1.
No. Remember, sine likes y. At 0 degrees, there's no y. right, so I really, this is one small reason, and I kind of mostly joke. I don't hate SOHCAHTOA, but this is one small reason that I strongly dislike. If you understand sine likes y, it makes it so much easier to memorize the values. Because like I said, in my head, I know sine is small when it's away from the y-axis, because sine likes y. If your fundamental is SOHCAHTOA, you don't make that connection as strongly, right? There's a lot of other things that come later. The stronger that connection is, the easier it's going to be for you. Now, what happens as the angle gets bigger, that input? What does sine do? What's the next value it takes on? What's sine of 30 degrees?
1/2.
Yeah. And then, of course, it kind of grows from there. Right, 2/2. What's this one?
Red, 3/2.
3/2. And, of course, it gets to its largest.
1.
All right, let's keep going a little bit. You got to leave some room to graph this damn thing. So now it gets a little bit freakier on the other side. Let's see, what are my options back here? So what are the 3 big ones here? I know I'm going to end up at pi. So the next one after pi/2, what is this guy right here?
2 pi over 3.
Good, 2 pi/3. And so this is kind of neat. Now watch this. That's 2 pi/3, and then 3 pi/4, and then 5 pi/6. I've got so much room here, and then pi. Isn't that kind of neat? It's kind of like that goes with that reference angle, that goes with that reference angle, that goes with that reference angle. Do you guys try to show you some neat things to notice so it's easier and to remember how to do this kind of stuff? All right. So what I just pointed out also helps you with the outputs. That goes with that reference angle. So what's the output here? That one. Right, so it builds up to 1, and then it shrinks back down to 0. All right, and what's it going to do after this? What's it going to do at the next? I kind of don't have to keep going. Right after pi, there's going to be 7
Negative.
pi/6. Yeah. And what's the output going to become for sine when I get down here? From 0, it goes down to -1/2. Okay, let me stop for a minute. Okay. So when you guys start to have to graph these things, you're really going to have to start to know your values, right? Now, right now, I understand if you have trouble looking at these things, you have to think in your head about the reference angles. And you know all the reference angle values here. So that's a pi/6 reference angle. That's why it's 1/2. It's negative because now I'm down there. All right, so that's all the table I'm going to make, because it's going to repeat the values. It's just going to be negative values. Up until when, of course? When does it become positive again? What angle do I have to get to?
2 pi.
2 pi, yeah. So I got to go all the way around there, and then it's positive again. Then it's up here. Yay! So let me see. I want to make sure. I'll just do this. It's easier. Oh, I haven't given myself enough room. All right. Let me focus on the positive. There we go. You can do it, Jeff. Am I going too much? Sort of. All right. Well, let's see if I can get far enough along. This is why I wish I had bought the larger whiteboard, but too bad for all of us. I didn't. Where am I at? You can do it, Jeff. I don't know, can you? There it is. All right, now watch. So 0 at 0. I know sine goes between 1 and -1. At pi over 6, which is right in there, pi over 6, it is 1/2. At pi over 4, it is rad 2 over 2. Now watch. When you're graphing this stuff by hand, it's fine to plug this in the calculator. That is roughly 0.7. You can double check me if you want to. All right, so 0.7 is a little bit above half. So it's about right there maybe. Pi over 2, it's 1. Pi over 3, it's rad 3 over 2. Pi over 3 is in here somewhere. So it's rad, oh, let me see. Whoa, oh, what have I done? Oh, yeah. All right, I skipped my poor little pi over 3. That's what happened. Square root of 3 over 2. Can somebody do that in the calculator real quick? I think it's 0.85 roughly. I don't know.
Yeah, 0.86 or 7. No.
We'll make it 0.9 because I can't be that precise. Pi over 3 is about right next to 1, and then pi over 2 is 1, and then it starts to come back down. So let me sort of just get the main things. I don't have to worry too much about the little in-betweens. Let's just worry about the 45-degree stuff just to get the idea. That's 0.7 again. Let me put some markers up here. That's 0.7. Pi at 0. 5 pi over 4. At 5 pi over 4, what's it gonna be? What's the number at all the over 4s? What number is it? 0.7. You guys with me?
Negative.
Negative. I love it. So it's gonna be negative 0.7, about right there. Then 3 pi over 2, it's gonna be negative 1. 7 pi over 4 is gonna be negative 0.7 again. So it's just gonna kind of do this forever, right? And it also, if you go back this way, same thing. It's just gonna do this shape forever. So real quick, let me, oh, look at that. That's so beautiful up there. So I was a little overly detailed in this. So when you graph these things, we'll have certain, do you remember when we graph things and then we transform them and there are base, what do I call them, anchor points? And then you shift them around. So we're going to talk about what the most important points on here, the anchor points. Obviously, it should be kind of obvious. They're the quarter points, quarter way, and so forth. And anyway, so we'll talk more about that when we start to, we're going to shift these things. You know that's going to happen. Every time we learn a new function, what's something we do? We move it around. Yay. We're going to, now these make even more sense when they talk about compression because it looks like a spring. So when I compress it, it's going to go crazy like that. And when I stretch it out, it's going to be, right? So the stretching and the compressing make so much more sense with trig functions because they're like springs. Okay, so let me show you this neat animation. I've got this thing somewhere, excuse me. Here we go. So this is kind of cool. So I want this to make a ton of sense, obviously, I always do. So do you guys see how we're at 0 degrees here, right? So as I move this slider, what it's going to do two things. It's going to change the angle I'm at. Now watch, see? So, whoa, that's really big. So let me go to right here, sure. So now I'm at this angle. And do you see it's plotting the output? I really want this to make all the sense in the world because this is such a beautiful thing. So it's showing me on the unit circle what angle I'm at, but it's plotting the output at that angle. I really want this. So now watch. So when I get to up here, I should be at pi over 2, right? About right in there somewhere. Sure enough, this is pi over 2 here. Let me see if I can get that. There we go. Right, that's pi over 2. And the output is this because that's how tall this thing is. It's at 1 now. This is kind of nice. So as I move around the circle, it plots how big the y piece is. That's what sine is, isn't it? Sine is related to the y piece. And of course, the minute I get to an angle that dips below, the outputs become negative. So it's basically just recreating the image that we made up on the board. Rio, what's up?
I have a question. Can you explain it again, please?
All right, so
Oh,
I
okay.
know this is a little confusing.
Yeah.
The reason this is confusing is because it's got the unit circle on there. So let me just zoom right in on the unit circle itself, right? So one way I can look at this is don't even pay attention to the green line. In fact, I think I can turn that off. Yes. No, I turned the circle off. All right, let me turn this other thing off. Here we go. So look, so right here, I'm just going around the circle. Woohoo, woohoo, right? Is that cool? That's just going around the circle.
What is
Yay.
the A?
Say again, sorry.
What is the A?
Oh, A is the angle that I want. So
Oh, okay.
what is pi divided by 2? Isn't pi like 3.14? So isn't pi divided by 2 about 1.57? Let me let you guys think about it. Pi is 3.141596, blah, 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 right? Everybody with me? So what's pi divided by 2? It's about 1.57. So whenever Jeff is at the deli and my number is 157, yeah, I geek out a little bit, okay? I'm sorry. So watch what happens when I get to about 1.57. Closest I can get is 1.6. Where am I? I'm at pi over 2, right? So the A is actually alpha, but that is the angle that I'm at. Everybody with me? That's the angle that I'm at. So so besides just having the unit circle sitting here, what they do is when I'm at 0.2, see how big the Y piece is? Isn't the Y piece about 0.2 also? Roughly? Are you guys out there? When I'm at 0.2 angle, how big, what's the Y piece of this? What's the Y piece? It looks to be about 0.2, correct? I like it. So the next thing that this thing does, and it's confusing, I understand, because it has two different things happening on the same picture, which is also why it's so freaking cool. The next thing this thing does is it graphs. Let me see if I can make this show me. See, this scale is in pi. I'm sorry, it's too bad. But here is 0.2 and there is 0.2. So it's graphing. The green line graphs the point angle, comma, Y value. That's what the green line is doing, which is what we did up here on the board. All right. So again, at the angle of 0.2 radians, my output is about 0.2. So what's happening on this axis? I'm at the point 0.2, comma, 0.2. Okay, so let me turn this back on. Oh, it is on there. There you go. Let me come back out. So as I move around the circle, my angle gets bigger and my output gets bigger until I get to 90 degrees. Then it turns, right? The Y piece gets smaller as my angle gets bigger, and then it gets to 0. And then, of course, it becomes negative. All right.
Okay. I just got it.
No
So
worries.
green line is the value of the
Oh, I'm sorry. Turn that off too quick because I got another animation I want to show you. Yeah, the green line is the value of the sine at the given angle.
Okay.
This is just the unit circle, which is not really a graph. It just shows the values. Here's the graph with the values.
We just did.
Yeah, which we just did on the board, just without the unit circle sitting there too. Now, here's another cool way to look at this. All right. You guys probably, it's okay if you don't find this as cool as I do. I understand. Where'd you go? Oh, here it is. This is kind of nifty. So we haven't talked about cosine yet, but you could probably guess it's going to look a lot like sine. So this is kind of neat. All right. So what I want you to understand about this is not the best I've seen of this, but I can't find another one besides this one. Do you see how it's tracing out a unit circle over time? And this is kind of like if somebody shown a flashlight. Why can I suddenly not speak? If I shine a flashlight that way against the wall, it's showing me the shadow of the circle's movement. And that is the Y piece of the movement. That is the sine function. This is the X piece of the movement. That would be this cosine function. That's kind of neat. Right? This has some other stuff too, I don't know. Oh, this one's kind of neat. Now watch. This is kind of a little older, but I'll go ahead and let this thing do its thing because I try to do this. This is explaining what a radian is. There's a radian, right? The length of a radius. So there's 2 radii. 3 radii. Give me a little bit. Okay. Do it. There we go. Okay, all right. So I don't know. That's kind of a neat. All right, that's kind of confusing. Okay, all right. Enough of that. I got a chat. I can't handle it. Oh, I'm sorry, buddy. He's already gone. Yeah, you can go ahead, buddy. I'm sorry. Now, so let's look at cosine, and cosine. Let's see if we can do cosine a little bit quicker. Let's see if we can do cosine without the XY table. So let me just make graph here. You still didn't give yourself enough room. That's all right. We'll just go back this way. All right, let's start at 0. Scale sucks. That's okay. Start at 0. We'll do 1 and -1 again because that's all that sine and cosine can go between. What is cosine of 0?
1.
1. I love it. So cosine starts at the maximum. Remember, sine started at 0. Cosine starts at 1. What's cosine of pi over 4? No. Pi over 4. What's cosine of pi over 4?
3 rad 2.
No.
No. Sorry.
Rad 2 over
Rad 2 over 2. Rad 2 over 2. That's where they both meet. Right? It's where cosine and sine are the same. That's where the inside of the root and the bottom are the same. Root 2 over 2, which is 0.7. What's cosine of pi over 2?
0.
0, because cosine likes x, and pi over 2 is where it's all y. Poor little dude. Then I got another 45-degree reference angle, right? So it's going to be 0.7 again. And then cosine of pi, it's all x back here. So cosine of pi is -1. And then this is beautiful. This is going to be a mirror image. So I didn't really make a point out of this earlier, which I should have, but that's all right, Jeff. What kind of symmetry does cosine have? Jeff, you can do it, buddy. What kind of symmetry does cosine have? What kind of symmetries are there? Why do you keep doing that? All right, let me remind you. There's even and odd. Do you guys remember what they were? Which? It's definitely even symmetry. How do you remember that? Even number parabola, even number power would be x squared. That looks like this. So what's even symmetry mean? It's symmetric like this. Symmetric like this. Now look at sine real quick. Let me see if I can graph sine up here real quick. So sine starts there, goes there, goes there, goes there. No, Jeff, you can do it, buddy. Yeah, you got it. Goes there. Why am I having trouble? It's 0 there. Oh yeah, because I got the little pi over 4. That's right. Whoa! What kind of symmetry does sine have?
Odd.
Totally odd. I like it because odd symmetry is through the origin. Right? I don't know if you guys remember. So if I go through the origin, I arrive at the same point on the other side. Shua! So sine has odd symmetry. Cosine has even symmetry. How far apart are those? Do you see how sine looks like a cosine shifted? By how much?
pi over 2.
By 90 degrees, by 90 degrees. And we know that's true. We know that they're off by 90 degrees, right? At 0, one is 0, the other one's 1. At 1, one is 1 and the other one's 0. They're off by 90 degrees. So the graph shows me that relationship. Okay, all right. So you know what's coming next. Oh, well, one thing that's coming next is tangent. We got to talk about the tangent function, what it looks like. We also have to start shifting these things. And with trig functions, since they represent like sound waves and all these different things, they have specific names for the different kind of shifts. For example, a vertical shift is related to its amplitude. Right? Again, anybody have an amp? Anybody play any music? So if you crank that up, it's increasing the intensity of the sound wave, which is really just changing the height of the sound wave. That's amplitude. If you change the frequency of it, you make the pitch higher or lower. That is a a horizontal compression or stretch. So everybody's sort of with me. Do you guys know about Doppler effect, for example? Anybody know what the Doppler effect is? I don't mean Doppler radar, no. Even
Sounds
though,
familiar.
yeah. So have you ever had an ambulance go by you? Could you imitate the sound of an ambulance going by you? Or even as a car, can somebody imitate the sound of a car driving past you? Now's your chance.
High pitch starting before, and then it gets stretched as it goes past.
Right, something like that, or yeah, it's really because the sound waves coming at you, they have a velocity towards you, so they're more compressed, higher pitch. When it gets past you, now they got to come at you, and they're also moving away from you, so they're more spread out, lower pitch. Holy shit! Oh, Julia, see, I was waiting. I was like, come on, people, anybody. So you had a chance. All right, guys, I think that's enough. That's enough for tonight. So, all right, maybe so. I stopped watching Big Bang Theory a long time ago. So tomorrow we'll keep going. We'll do the trig. We'll do the tangent function. We'll start talking about the shifts of these things. And the quiz is Monday, of course. I've got the practice quiz up. I don't know. I'll get the answer key up at some point. I don't know. The solution video. We'll see when I get it up. The solution video. All right, guys. That's all for today. So let me know if you need to hang out. Otherwise, you're free to go. Chapter 7 is what the quiz is on. Yes.
I have a question.
Yes.
What is the degree for 1 radius?
For 1 radian.
1 radian?
Okay. So how do you translate a radian into degrees? Well, the quiz is on Monday, Paul.
Kind of forgot.
All right. So how many radians equals how many degrees? What's this also? That's pi radians. It's also 180 degrees.
Yeah.
So that's the fundamental translation between them. So if I have 1 radian, I can translate that into degrees like that. So 1 radian is 180 divided by pi.
Oh, so the degree can have a pi in it?
Yeah, of course. You could have pi degrees. Why not?
Oh, okay. So it'd be like 180 over pi.
Yeah,
Degree.
but if you want to get an estimation for it, you just go ahead and do that division. I think it's 57 point something, right? Let's see. 180 divided by pi. Yeah, 57.3, basically. So 1 radian is roughly almost 60 degrees.
Okay, thank you.
Yeah, you're welcome.
Have a good one.
Good. Everybody else okay?
Yeah, that was just pretty cool. So I wanted to listen to it.
Oh,
Have a good
yeah.
night.
Take care. See you guys. I'm out of here.